Hello and welcome to the Junos live session. At this time, all participants are in a listen-only mode. If you have a question at any time during the presentation, please type it in the Q&A box on your screen. I would now like to turn the floor over to Rob Cameron.
Welcome and thanks everybody for joining us here on this wonderful very mid October day. My name is Rob Cameron. I'm principal engineer in the security intelligence team. The next question when I say that always is, what the heck does that mean? Are we spying on foreign bodies? No. I work on analytics of security information, automation, and attack mitigation. So we're basically doing primarily research around the security field, primarily around stats and aggregation. So somewhat of a data nerd. So a little bit more background. I've been here at Juniper for 8 years. In my past, besides working at Juniper, I've been a consultant, a value-added reseller. I've worked and done social engineering for some security analysis. I've been a systems engineer, or basically an SC sales engineer for Juniper, solutions architect, technical marketing engineer, and now working inside of R&D. I'm a 5-time author, and obviously I'm a really good author because I can spell author correctly there on that line. Worked on the first ScreenOS book and first Junos security book. And I'm currently co-authoring Junos Security 2nd Edition, which will come out in Q1 of 13. You can follow me on Twitter or app.net as RobWCam if you ever have questions or anything that you want to know about Junos or perhaps about this webinar. Feel free to hit me up with messages. Just a little also background, I love JavaScript programming. We'll talk about that. MongoDB, which is a NoSQL database, good sarsaparilla, and I love Junos, of course. So let's go ahead and get started here. So the basic discussion point that I want to go over today is talking a little bit about Junos Automation. So as customers, the migration to ScreenOS started around 4 years from to SRX. People have had questions around how can I make my SRX experience more like ScreenOS. Now, of course, we can't go on and throw that ScreenOS web UI on, or we can't go ahead and completely replace the CLI for certain reasons. We can bring back some of those good feelings that we had with ScreenOS or simple commands. One of the biggest challenges of Junos is that it has a lot of features and a lot of options. And I say challenges because initially navigating that, maybe can be very difficult to begin with. But there's a lot of ways to make that Junos experience much more ScreenOS-like. So we're going to go over an example today around the Git interfaces command, and I think it's a good basic example because we don't want to go from 0 to 100 in programming. We don't want to jump right off the stratosphere. And I want to talk a little bit about automating automation, and we'll get into that towards the end of the presentation. So Junos Automation is basically a script when you write it on Box. You can write that script in one of 2 languages, Slack or XSLT. So what does that really mean? So the native way you're writing is actually an XSLT, which is what we're going to talk about and demonstrate today. The reason for that is because the alternative, Slack, stands for Syntax Language Alternative XSLT, or basically it's a layover language that makes XSLT a little less scary. So we'll talk about the benefits of both and how you can utilize them. We talk about choosing a use case, about when you want to write your first script, and doing something easy to begin with. With scripting, you can do a lot. Let me give examples. Today, we're just going to modify the output of interfaces, but I've also used scripts to be able to do advanced research inside of a device. I've done it to write a high availability code for some very large customers. And there are so many people that now are in the Junos community that have really expanded into the scripting. It just really blows my mind the things they're capable of. We want to talk about going one step at a time as we're programming this. Programming at the very beginning is very, very difficult. It's something that's very challenging because it's a different way to think, I like to say. But the good news is that actually the programming experience isn't too much different from actually configuring Junos. You're basically setting some commands and then setting up options to be able to operate with those commands. Now, when you're going and programming things, we often talk about in the networking world best practices or real-world scenarios. So in programming, you have the idea of something called design patterns. And what that means is that you're using a series of patterns or formulas or styling to solve a problem. Now, they're really not called just a best practice because it's something that you're designing a pattern to it. It's not exactly the same. And an example would be if you were going to knit a sweater. I can knit a sweater for somebody who is an XXL or a small. I'm using a pattern to knit them, but the actual implementation is going to be a little bit different about how much yarn I'm going to use and whatnot. So enough about knitting. Let's continue to talk here about our scripting. When scripting, there are three, but really two main types of scripts. One being an operational script, and one being a commit script. Today we're going to talk about operational scripts and how to run those. What we have here is an operational script. It's something that's initiated by the user, executes some series of commands, and then generates your output. It can change config, reboot the device, basically anything you can run from a command. However, it's executed by the user. You can do this exact same thing and run it as what's called an event script. This is a task-based script that's based on an event. Let me give you an example. An interface goes down. You can review that interface, perhaps make some configuration changes. The programming model is the same way as you do in operational programming. Lastly, you have a commit script. This is very different than an operational script. What this does is upon committing your configuration, when you make a change, it applies XSLT transform to the XML backend config. So what that really means is, as we chose XSLT for the programming language, XSLT is designed to take XML in and output it to, say, XML, HTML, something like that. So with the commit script, what we're doing is we're inputting the config, making modifications based upon our configuration script, and then outputting those to the actual end config. Examples of what you would do for that. Let's say you had a policy in your corporation where you did not want to commit a firewall policy that had the option any set, meaning that you always had to define specific hosts. You could have a commit script that would deny a commit if the option any was set in source or address or application. So that's a very powerful feature to be able to use. Many service providers and organizations use that to be able to prevent issues from occurring as you're building a network. Nothing's worse than you accidentally delete the interface of Stanza, and boom, your router has no interface as a firewall. Not very much useful in that case. So with a commit script, you can prevent this type of thing. So running a script, what does this mean? How do we get it on box? So a little bit later, we're going to go into the actual live using of the scripts, but I want to explain now a little bit right now what this means. In Junos, there is a directory, /DB scripts, and this is where we store the scripts. There are several different directories there, but the one we're going to focus on today is called op, or operational. You would place scripts in there, and you can FTP them over, do an HTTP GET, we'll show that, or just VI and copy and paste it over. Any way you can really get it over there is possible. Also using things like security design in Junos Space, there's a way to manage scripts for deployment on your devices. There's a lot of ways to skin this cat per se, and we're just going to talk about the basic ones of just using VI and copy and paste. To enable the script, it's really simple. You just run one command, set system scripts, op file, and the file name. Or alternatively, instead of having to copy it over, we talked about the HTTP GET, you could actually host it on your laptop or a web server and just go and point it to that, and it'll automatically copy it down to the device. So this is great. So imagine you're deploying, say, a couple hundred SRXs. You want to have the same, configuration on it, whatever. You can actually just put a script to bootstrap the configuration. So you could go ahead and set, I want to set DNS and host name or something. You run in, you copy the script over from your central location, you run the script, and it can configure all that stuff for you. This is great for mass deployments, any scenario where you need to easily transfer the script over. So then from there, running a script is very simple. You just type op, space, and the file name with no extension. You can also give an alias to that command as well. Because one of the things that we often get a question for is, why doesn't Junos have an alias command? And I agree that it definitely should, much like ScreenOS and several other operating systems have. However, what people usually do for this type of scenario is you can actually build a very simple script, which we'll demonstrate today, to basically provide that alias for you. So again, executing the script from operational mode, just op, space, and the script name. In that case, we just call it script -fun. So I wanted to focus specifically on one example today. I was originally going to do 4, but then I kind of thought about a programming class that I was at a long time ago in college, where 2 people were arguing. One person wanted more examples that were simpler, and the other person wanted a more in-depth example to learn how all the technologies work. And it kind of brought me to that Bud Light tastes great, less filling argument. And I think I'd rather have a tastes great than a less filling, right? So we're going to focus on interfaces management with Git interface. I will also point you to, at the end of the webinar, a policy script that actually can give you the same output as the Git policies from ScreenOS. So a few tips before we start talking about our journey through XSLT and Flask. The biggest challenge that I find, which we'll talk about and demonstrate, is being able to find your data inside of the XML. And as we look at the XML configuration, you're basically going to use a language or a syntax type called XPath, which for long and the short of it is kind of like an SQL select statement, but for XML. It's a lot easier than SQL because you don't have to deal with weird joins and all those types of stuff. You're basically just going through what will look like a lot like a directory structure. To me, I find this is the biggest challenge because as you're iterating through hundreds and hundreds of lines of data of XML, it's hard to identify exactly where you're pulling this data from. So we'll talk about some tips and tricks to do that. And finding that XML has actually become a lot easier. So I think it's as of like Junos 10.2, we'll just go with that. You can actually display not only the XML output of a command, but actually get what the XML command would be. And we'll take a look at that right here. And then lastly, before we get into the real deal stuff here, we have a Day 1 book, Applying Junos Automation. Awesome, awesome book. It's Flask-based, as most Junos materials are, because, again, that's our language of choice for doing this, and I think it's a little bit easier. Great documentation, even though, work at Juniper, been doing this for a long time, still refer to the configuration automation guide. Amazing document. And really, just, you got to start doing it. I mean, a long time ago, I wanted to learn programming, and I just didn't get it. But time and time again, I worked at it, and that's really the only way to get started. There's an initial cost of doing of getting started about learning some of the basics, but really, as you do it more and more, it gets easier. I mean, today, primarily, I do programming, and I thought I would never get here, and I just did it because I did it every day. So let's get started and share my desktop and take a look at real scripting. So now we'll give a moment, and you should be able to see my desktop here. On my left-hand side here, we're going to start in my XML editor, which I use Oxygen XML. This is an amazing tool, and honestly, most of my Juno scripts that I write in XSLT would not be possible if it wasn't for this tool. It does simple syntax checking, simple shortcut things like that. The price on it ranges, I think, from 100 to 300, but there are a lot of other tools out there. I particularly use Oxygen because it's a Java-based tool that supports Mac, Windows, and Linux, and on any given day, I can use Mac, Windows, and Linux, so it's a great tool. There's also things on Windows, specifically like XML Spy, or heck, there's so many different editors today that just pick one, you Google it, and I'm sure you can find something that's very useful for you. Ultimately, due to the way that we have to work with the script, there isn't a complete integrated solution today for doing the testing, debugging, and whatnot for the scripting. But we'll talk a little bit about how these types of tools, the XML tools, can help us. So on the left here, we have that window. On the right here, we're going to have my SRX cluster, which is sitting to the right of me here. And this is what we're going to use as we're doing our demonstration. We just have the operational and the configuration mode at the top, operational at the bottom, so easier to switch around. And then lastly, I'm going to use DBEdit here, which is this Mac text editor. It's been around for a long time to do and look at Flask. Let's go ahead here and start by taking a look at a very basic script, which is basically the baseline script. The baseline script here on the left defines what we're going to be able to use as the minimum to get a script to run. This will actually do nothing except open up a CLI session in the background, and besides that, it will just terminate and not do anything. So we'll talk about what's important here. And on the right, we have the exact same script in Slack. And what you can notice between the two is pretty obvious, the important changes here. One, on the left, we have this, basically this XML stanza, as being XSLT. That can be very difficult to get into initially because you have to type all these, left and right brackets and all these colons and variable names and things like that. And the Slack syntax on the right simplifies it a bit. Now, the good news is that since I'm stubborn and still programming XSLT, there's a great way to convert between the two. Actually, you can take any XSLT box or any XSLT script, any Slack script, and just convert between the two on box. And that's very simple to do. So as we go through this, we'll talk about how we can convert that. So that way, for old curmudgeons like me, I can go ahead and use XSLT and show it to somebody in Slack, and it's no big deal to do. So the basics we have here is that we define this XSLT style sheet, but let's just ignore that because that's something that is great detail for XSLT, but we want to get to the meat here. What we're doing initially is we're importing an additional file to give us some additional options for different Junos commands. And these are very important to help with some various transitions. This is going to be at the beginning of any script. And these scripts, again, will be available for download, so you can just copy and start some space on. The most important thing we see here is that we create a global variable that allows you to create a connection to the Junos device. And what's great about this is we see this command, JCS open, and this command will actually create a connection to the local device by default or to a remote device. So you could have a script that would maybe operate on a local device and an HA cluster member. You can connect to any real device from it, which is great. Here we define what's known as a variable. And a variable is just a name that we apply, and we create a value that associated with that name. That's all it really is. It's a very, very simple idea. The variable value can be a lot of different things. It could be an XML stanza. It could be something that is in here we have a connection handle. It could be a lot of different things. But it's basically this thing that varies and changes. Now, the thing that's a little funny about XSLT that we won't really have to deal with today is that variables in XSLT are non-mutable, meaning once you set a variable, I can never change it. And that's very weird because it's called a variable because it varies, but we cannot change it. So what's awesome is that folks over at Juniper in Slack allows you to create mutable variables or variables that you can change. This is much more traditional than what a variable would be. So you can use mutable variables in Slack, which is another great advantage of utilizing Slack. So since we're doing an XSLT transform ultimately, we use these concepts of templates. Now, templates are very similar to a programming concept called a function. And what that means is that you basically take a series of code that you call based upon an event. So a function, normally you would give it a name and call it like shoe or sock, and then call that function. And the reason that in XSLT we call them templates is because this is a template that's applied to a specific set of XML. So a good example would be if I had a set of XML of, say, like records, Bob Dylan, Jimi Hendrix, whatever, and it had all this different information about it, I could say match anything that is a record and then transform it into something else. So that's where that name template comes from. For here, we're just calling match /, which basically is just match the root of the document. For most of your work, for the basics, you never need to modify this. You would just use this exact template here. So for our example, we're going to take a command and grab the output, and then from that output, modify it. So the first thing we need to do is identify what command we're going to grab and how we're going to send that into the script. And this is by identifying the RPC, or remote procedure call, that we need to execute. So there's a few ways to do this. So if we go onto our Junos device on the right, we want to basically execute the command show interfaces. And we can do that, and we have this text output. And this text output, of course, is not going to do a lot to help the computer because the computer doesn't understand the context of any of that text. So what we can do is we can do show interfaces, type display, and this is something that's a common command for configurations to do a set display, which is something that you would see for a configuration. So if I do show configuration, for example, we have that Junos hierarchy for configuration. we can actually do pipe display set and make it more ScreenOS-like, or a command that sets the option. So we can do that same thing with a show interfaces command. We can do pipe display, but here we don't have set because we're not setting anything. But we can look at the XML RPC. And what this does is this tells us the RPC command that we want to use for the scripting. So we see this part here. We see an RPC reply, which is basically the envelope carrying this message. We don't need to worry about that. The part that we're interested in here is showing that RPC, which is at the top. And we're actually going to take that, copy it, and use that as the actual command that we're going to run. And then we're also going to save this as an example so we can keep the baseline as it. So this is the command that's actually going to be run. Now, how do we know this is going to work? That is a great question. Now, what wouldn't it be nice is if we could kind of get like a session going where we could actually do it, talk via XML. Well, that's actually quite easy to use using this command Junos script. This hidden command Junos script to be able to execute Junos scripts interactively. Now, this actually would bring up what's called a Junos script session, something that you would have over the wire. And there's a few different ways to do that. The traditional Junos script language, or Junos script remote connection, is done, and it requires some authentication via the XML, and it's a little bit messy to deal with. So we can actually do netcomp, which is the RFC-based version of this RPC, XML RPC integration, or Junos script, and we can call interactive. So Junos script netcomp interactive, and boom, we're going to go ahead and initialize a Junos script session here right on the device. Now, this actually is what is the exact same protocol we use for space management, security design, NSM, all of these different things, and you're going to interact with it directly. So what is this netcomp? So let's look at exactly what that is. We have a file here called netcomp in this hidden directory. And what actually happens is when we run this command, or we do an SSH netcomp session or DMI, we're just running the CLI and forcing it to operate in XML mode. This is just simply a shell script that calls and initializes it. So even if you're using the XML interface, it's actually just a CLI underneath the covers, which I think is great. So you're not doing something that's a completely different implementation. So here, back to our session, we can go ahead and take this RPC, simply paste it in, and boom, the command runs and we get the output. And this is the exact same thing that's going on behind the covers as you're running the command. So we see the XML output. Now, it continues to go because there's a lot of information there, and we're just going to end that session because we want to see that same XML, but we want to see it in a more human-readable format with indentation and whatnot. So we'll do the command, show interfaces, pipe display, XML, because we want to see the output, not the command. And here we go, and we're going to see the output of that XML. Now, what this is doing is it's wrapping all of this output from the command into XML. Why? Now, if I told a computer my address is 1234 Fantasy Lane, okay, great. We can send it to Google and it can figure that out. But if I just tell a basic system, it has no context that that's my address. We can figure that out, and Google, with their 100 bajillion computers, or IBM Watson, can kind of just figure out the context of that, but a computer cannot. And so what XML is doing is it's wrapping the actual data in some sort of format to be able to identify what that data is. So one of the things we're going to need to pull is the interface name. And here, what we define in the XML is we see physical interface and name. So that way the computer can understand what that data is. Now, again, just by having those tags, it's not like it magically figures it out and it's going to deliver me flowers or something if it's really an address. It just allows us to pull that data and use it. And we're going to see that here on the left. So this is the output that we're going to get by executing this command. So on the left here, we have the RPC, and it's set into a variable. And then we need to execute that command. So how do we do it? we run this JCS execute, which will actually execute the command RPC that we have configured here. Now, there's a few ways to do this. The original way was not called execute, it was called invoke. And what invoke would do is it would create a new CLI connection, execute your command, and then exit. Now, the problem with that is that cost of creating that connection, you're spawning up a new CLI, you're spawning up a lot of configuration elements, it takes a lot of load on the SRX or really any Junos device. And when I say a lot of load, it's not like it's to the boiling point of the processors. It just takes effort to allocate memory, things like that. And what we don't want to do is if we run, say, 50 commands, create 50 CLI sessions and exit them, it would just take way too long. So later, around the 9x timeframe of Junos, they added this execute command, which allows us to have one persistent connection, as we defined up here, and then run a command against it. And this will go ahead and execute the command for us. Now, right here, what we see is that we can take this command, get interface information, execute it, and then we store the output in command result. This is great. Now we have the output, but we need to be able to manipulate that and share that information. So to do that, we have this output tag here, this opera script results output tag, which again, you never really need to modify this. You would just use the baseline, and I do that as well. I mean, I've been doing this for a long time, but still, why type all this every time? And we just need to output information here. A couple ways to do this is using the printf command, and this is not the actual code, I'm just typing it in. Printf is a very standard, it's been around for a long time in VSC, to a print format to format the output so we can make it look how we want it to. Or the other option is to do output command, which we'll talk about as well, and the output command basically takes your text and wraps it in this XML output command, this XML output tag. And all that tells the CLI is display the text that's between these output brackets. And that's all it does. So by default, we can just use the baseline, copy and paste our output right here, and we don't have to worry about making any significant changes or efforts here. So now that we have this command output, what do we want to output? Well, what I want to do is I want to bring up the ScreenOS-like commands, or the ScreenOS-like output. So if I bring up, let's see if I have that here. Fortunately, I don't have that, but I want to bring up that tabular format that ScreenOS has. Now the thing is that let's say Juniper just went ahead and copied ScreenOS CLI one for one. Junos is so much more rich in the networking side that it's not simply just compatible, meaning that we have a lot more options, a lot of different options that we want to be able to configure and see. And it's just something that from a one-to-one perspective, it wouldn't work. But using that familiar output is something that we want to get to. So the default output of show interfaces, it's basically very long, takes a long time to go through. And for some reason, it's hanging up here. Maybe somebody was in the HA cluster. But it's very long, hard to go through. Now, the reason that Junos is done this way is it's very, very detailed in all the information you can get. So you can actually, with your commands in Junos, again, do a simple command that would show it the interfaces in a little bit easier to read format. But again, for some people, this is just too much information still. We want to see the interfaces that I care about. So the command that we're actually going to create here is, I have it set up, is the get interfaces command, which we've seen from ScreenOS. And what this will do is it's going, running, creating that connection for us, executing this RPC get interfaces, and then transforming it into the output that we want. And here we go. So instead of this hierarchy, or this very detailed hierarchy here of information, what we have is the very similar ScreenOS table that we were familiar with. You have your name, IP address, zone, MAC, and state, and boom, here's your information. This is a very simple configuration, so really the two interfaces that we care about for traffic are the interface RF0 and RF1, or REF0, REF1, and it tells you the IP address, the zone, MAC address, state. Very simple. So how did we get to that? So we took the same base template, and here's the actual output of the script. So what we've expanded here, and I'll go expand this window so we can see all of it, is we are looking for, and we're going to pull out that individual interface information. So initially here, we want to print the header table, the header part, for this part here we see here, name, IP address, zone, state. And for that, we're doing everything with the printf command, because that allows us to format the output to show how we want it. So this very strange series of characters here is actually defining that output that we see here and how it's formulated. So what we're using is the this %s is the basics of it. And what this is saying is display string. On the right here, we're passing our argument, which is name, IP address, zone, MAC, and state, and those are being interpolated by these output options here and formatted into the text that we see. So we're fundamentally just saying print this string or this text. And we're offering here a little bit of formatting guidance. The minus meaning align to the left, and the 15 saying give me 15 spaces. Now, there's a lot of options here for printf that you can do, and I just simply go to Wikipedia or similar other reference, and it tells you what they are. Even in the Junos configuration documents, it does not actually detail all of the output options via printf, but it's something that, again, is a standard throughout all the languages. What it does highlight in the configuration is or in the documentation are some specific things that we added to the printf, the ability to do capitalization and things like that. But let's not get too focused on every option. Let's get focused on setting up this script. So this here is going to show the output of that header. Now, if we go ahead and let's kind of mangle this up a little bit, we're going to take this script and paste it over our baseline example, so we can modify it. What we're going to do is if we take everything else out, except that, and we're going to take this and run this actually on the SRX. So just very simply, we can do an edit var dd scripts op, which is as I said, and this is actually where we store all these files. So we'll just call this one get int, because we call the other one get interfaces. We just simply paste that in the directory, and now we're going to activate this script. So to do that, we go to edit system scripts, as we talked about before, and this is where we would just simply define that script. So set op file get int.xsl. And by default, it's going to look in that directory, var dd scripts op. We're going to just go to the top of our configuration and commit, and we should be able to run this script shortly. Now, what's nice is once you define the script, you can actually go back to the command line and edit it to all of your heart's content, and you do not have to redefine it. It just simply reads upon that script upon execution, and that's all really it does. So from a debugging mechanism, what are some of the best options we can do here? We can just simply have this text window open in a very simple way and just VI, copy, paste, and insert, no big deal, and do that over and over again. Or another option that we can do is actually set up something like SSHFS or FTP, and that's available with different things like secure CRT, secure FX, PuTTY, whatnot, and actually mount this directory as a local disk to be able to do editing. And if you're doing very large scripts, I mean, that's something that I definitely suggest to do. If you're doing small scripts like this that are just sub 100 lines, it's just not something that you necessarily need to worry about copying and pasting stuff. So our command completed here, and we're just going to go ahead and do run pop, and we can do get int. And this is going to run the command that we just pasted in from the left-hand side. And again, it takes a moment here to start up and run that connection on the script, and then that'll go ahead and give us the output. And all we had here originally was that printf command, and that basically just sets the header. You can go ahead and do that display XML, and this will actually display the XML output of the command that's not formatted. And what we'll see in this is just our header, and we'll see those output tags that we've defined here on the left that shows that we're outputting that information. And I'll just take a moment here to execute. And here we see, here's that header that we're printing out, and then here's the output tags that we're putting around it. And that's all. This tells the Junos CLI showed that information. Okay, so let's take a little bit farther and actually start looking inside of the XML. So what we're going to do is, let me bring up here, show interfaces, type display XML. Is what we want to do here is we want to pull out particularly the logical interface information, or basically the thing that has the IP addresses defined. And what we can see here in the XML, expand this a little bit, is that we're originally just saying this is the physical interface information. And let me pull off, go down here and pull off the actual XML for the REs we want to take a look at. FXP, well, FXP, okay, we'll just take it off. So see how much information is just shown here? And we're going to go back to just this text editor and go ahead and paste this in. Now this is the XML that we have to wrangle through and find that information that we want. So let's use the RE as an example, since that has a logical interface defined. And find that in the XML. There we go. So we'll use FXP0 here since we can't find the RE. What we have here is this is all the information for FXP0. It defines the physical interface FXP0, which is just the management interface. And then to actually find the IP addressing, that would be done under the logical interface here. So we want to find, let's see, 170.10.0.1.253. Not showing it. Fine. 10.0.1.2.1. I must have missed that in XML. So let's do this. We can use our Junos commands here to find match, and then do match 10.0.2.1, which is the actual IP address that we want to pull from that XML. Let's see if I have an example here as well. That's a later example. All right, so here we go. Oh, we have a question here, and let me go back to that in just one moment here. What we're looking for is this ISA local here, which is the local IP address in the XML. So what we need to do is break through and loop through the physical interfaces. Let me go ahead and see and just briefly take this question here and see if I may be perhaps missing something that we can better share here. Norman, go ahead and ask the question here. Let me just switch back. Norman, did you have a question? You can type it in the chat. While we're waiting, see if Norman here has a question, which is raising his hand. Ronnie had asked here, is it possible to work with the SRX like ScreenOS commands? So you're talking about specifically that you want to look at using this exact same ScreenOS command, so like you don't have to do show, you could just do get, things like that. If you're looking for something like that, unfortunately, there isn't a particular way to just do aliases and doing get versus show, things like that. Sure. So why should we use the scripts instead of the conversion tool from Juniper? Great question. So the conversion tool basically takes the config from a ScreenOS command or a device and would actually just go ahead and convert it over to the Junos config. If you're going to do a migration between ScreenOS to Junos, that's exactly what you would do. You'd use either our our online S2J tool, or also looking at using, say, professional services as well as a scripting mechanism to do it. Primarily with the scripting, what you're going to do is you're going to bring up a ScreenOS-like experience using the scripting. And the point of that being is that you may have operators in a large network that are familiar for looking for specific output, or you want to see a specific output in a very different way. Meaning that if I want to go ahead and look at show interfaces first, which is just a very basic output command, this may be something that initially is very confusing. And let me give you an example why. GRE interface, IP, IRB, LO this, LO that. I mean, some people look at this initially and say, what the heck are we doing here? This is very, very confusing. That's why using these types of commands, you can actually simplify the output of the command. And it just tailors it more to the experience that operators and administrators would like. And the thing is that, again, one of the best strengths of Junos, if not a downside for newcomers, is that the amount of the information that is actually sent out via these commands. And if you just went and did like show interfaces, which would be the basics, it's just way too much information for someone to look at. So all this really does, from the scripting perspective, is it simplifies the way that we can look at the output of the command. And this doesn't have to be mutually exclusive to something that's in ScreenOS. You could actually just simplify, like if I wanted to say, is my firewall up and running, like show, or my IPS is a good example, show security, IDP status. You get a huge output here about what's running, what's not running, all these different stats. You could just create a script that said, yes, IPS is running, here's your policy. That makes a lot of difference for administrators and making their day-to-day life simple. So you'd have a root administrator being able to define this, and then the Juniper administrators being able to use that command. So from a migration perspective, you wouldn't typically use the scripting. So to kind of continue to get through our example here, what we have to do is go through that massive set of XML and pull out just the information we want to do, we want to see. So what we're going to do is we're going to take the output of that command that's stored here in command results, and then iterate over it using the for each command. And what that basically says is take the output of this huge XML and break it up into smaller pieces. So what we're doing is we're actually taking this into these physical interface sections, breaking it up into multiple areas and processing them one at a time. And that just makes it a lot simpler for processing and dealing with the XML. Now, we could try to do this all at once, but hey, life's about making it a little simpler, right? So in here, what we're saying is give me each physical interface in all of the XML. And now we can work through that individually. So for doing this, our XML is now located at the dot command, which is basically just local to this. So we don't have to reference anything. The dot is basically referencing all the XML that we have. And what we want to do is pull off individual pieces of information. So for here, what we're doing is we're pulling off the name of the interface, its operational status, and then we're going to go ahead and make actually a variable here that will take the physical address, which is the MAC address, and if it is defined, we're going to output it, and if there is not a MAC address defined, we're just going to say NA. And what we're doing with this is just a very simple statement called choose when, which is just like an if statement for very basic programming. So if, then else, if, then. They called it choose and when. Again, the XSLT gurus, I guess, thought it was a good idea at the time. And it's a very simple idea to show here. And what we're basically saying is when there's a current physical address or MAC address and it's not blank, go ahead and let's go ahead and select that as the current physical address. If not, we'll just choose to go with NA here, or not applicable. And then from there, we're going to go over each logical interface and pull out the name, the zone name, IP address, and we're going to pull off the mask, which we had to do a little bit of extra work here to be able to pull the mask off because it's actually on a different part of the command here. And we'll save that as kind of an advanced piece. And then we just concatenate all that together into a full address, and then we're going to output that as an individual line. So when we run this command here, opt-get interfaces, which is the command that we're running, that we're writing up here on the left, this will go ahead and it's going to iterate over each individual option or each individual interface XML, and then it's going to print this in this easy-to-use table. Now, it shows all of these because these are logical interfaces that are defined, but they do not have an IP address. The zone is null. The state is currently up, and it just lists the MAC address. For FXP1 and FXP0, it does not have a zone because those are not zone-based interfaces. But we also have the fabric interfaces, which are used for HA. And again, primarily the things that we're looking at are RH0, RH1, that we see at the bottom. So as we talked about those annoying interfaces, we can actually go ahead and easily filter them out from this output. So FXP1 is a logical interface that is between the control plane and the data plane inside of the SRX. You can never really see it, but it's something that's there. And Norman, just since we're getting towards the end, I'll save your question for the end and come back to it. Thank you. So with that being said, we want to go ahead and just simplify this output by removing this FXP1 interface. So I have done a little bit of this already and removing these annoying LO0 internal interfaces that we're not particularly using. And so we can actually go ahead and, as we're going through the various logical interfaces, create a new option here and identify that if the name is equal to this annoying FXP1 interface, and we're going to just do a comment here and do nothing because we don't want to see it. And we can go ahead and take this back to our device, edit the correct file, delete through here, and go ahead and paste our script in, just save it, and then go back and run the command, and we should no longer have to see the FXP1. Now, I make little notes here because the FXP1 and all these internal interfaces are great, but from a basics operations person's perspective, or really if you don't have to care about it or don't have to look at it, why have to see it? And now, as we can see, we've eliminated the need to see the FXP1 interface output from this command, whereas before we did see that. So this is something that, as a beginning Junos user, they would look at it and say, wow, like I don't understand all these logical interfaces and why these are here. To save that example, boom, you just go ahead and being able to eliminate that through the scripting mechanism here. Now, the interfaces component is a very simple example, but there are other things, like if you were going to manipulate policies, and then I'll point to the policy script, you may want to see something that is more tabular based. So those current ways you look at policies, I mean, it's great from a, I don't know, XML perspective if you want to look through it, but it misses that awesome tabular policy formatting that ScreenOS had. And that's something that the policy scripting will show, and I'll point to that here as we start to wrap up. So as we're kind of running out of time, I want to save time for questions. The important part I want to note here is that this template here, both the baseline and the Git interfaces template, is something that we're making available right now. So if we go simply to a website called GitHub, which is one of the sites that I use all the time, I created right here the SOS to Junos webinar, and this contains all the scripts that we see here today. There's also some additional scripts here that we use. These are some HA scripts, Task Agent, Action Agent, SRX Monitor, port mirroring and script, and this is the Git policy script that we talked about as well. I didn't want to go over this in particular because this is something that has a lot of different muxing with here as it gets to be around 500 lines. So it may be a little bit more difficult to explain here in the short period of time. But you need simply just go over here to GitHub and download this for free. These are all just open source. There's also Junos Scriptorium. Let's see, Junos Script. Here, that's hosted on Google Code that will show here in the slides. You can also go as well, and there's many, many different scripts here available for download through the source tree that we see here. And this is the official Junos repository. I don't always necessarily use this because I may make little one-off scripts and I don't want to muddy the waters of the official repository. But there's a lot of other scripts here that you can use to see, and they have it in both Slacks. Typically, most of them are written in Slacks. So both of those are also available. Now, one of the things I find challenging here about scripting is the fact of programming, because most folks that are in networking don't have the opportunity to work with or use programming on a day-to-day basis. So what I started doing as some research is creating a tool to make life easy and make this a little bit simpler. So unfortunately, I don't have a mock-up of the tool, but the idea would be is you could take your XML output, simply drag it here, and then do a little drag and drop to be able to configure and look at the various options that you want for the output. So really what you're doing then is building a script via drag and drop with no programming knowledge at all. And if this is something that people are interested in, just say in the chat, yes, I'm interested in it. And perhaps in a quarter or so, we can have a webinar and perhaps display that script, that tool, and show how you could use it so you could automate without needing to know automation. This little demonstration here that I have is actually pretty cool. It's a little back-end web server, and what it does is it takes the Junos config that I'm dumping here. It automatically parses it on the back end to JSON, which is a JavaScript object notation, or just the native JavaScript data format. And it actually goes ahead and saves it back to a back-end MongoDB database. So as I'm looking throughout the day with Junos configs, I don't want to have to deal with how do I save this config and back it up. Boom, I just drag and drop the text via HTML5, goes to the back end, parses, and saves it. And this is what I'm using kind of as the basis for that potential scripting thing. So if that's something you're interested in, please give feedback for the webinar, and we can take the scripting out of scripting. And I would definitely be happy to work on that in my time as I'm wrapping up my book efforts here. So as we're kind of running towards the end of the hour, if this is something that you found useful and we want to continue this session, we could look at having another webinar to continue the programming discussion. And then again, in maybe a quarter or so, have a webinar to talk about this scriptless scripting automation tool. So I'm going to go back to the slides here. And if anybody has questions, please type it in the Q&A, and we'll go over those here as we wrap up. Here are all the examples, and in that actual on the GitHub that we list here, GitHub/Juniper Networks, I'm going to put this file in there so you have all the links for all the other sites. You have the Junos Scriptorium, which is the official script repository, then Juniper Networks, which is where I store some of it, the webinar that we created here, RobWC, which is my personal scripting stuff, so there may be some other projects there they may be interested in. And always what's great is, just utilize here on the JNet forums. I don't particularly spend a lot of time there, unfortunately, just doing a lot of other research and things, but there's a lot of folks on there that answer the tough questions. So as you get stuck, please feel free to reach out. And that's one of the things I think GitHub has done great for the programming community, is it's kind of like, for lack of a better example, like the Facebook of programming, and it allows you to do social coding, to actually share your coding knowledge and very simply work together with other people you may have never met. And that I think is a great thing. So the Scriptorium, or the JNet form here, allows you to go in and ask questions, things like that. And ultimately, if you want to just hit me up with a question, just tweet me at RobWCam. I use Twitter all the time. I think it's a great tool. It's not the only tool we need in the world, but I think it's great for simple communication. So if you have some questions, tweet me up, mention me, and then we can get in contact and discuss any questions that you may have. So for the presentation, that is it. So let me go ahead here for the questions. We answered that one, we answered this one. Okay, so before we get the scripts answered. Can we use the XML output, can you use the XML output from NSM deltas and apply those changes to the XML netconf? Yes. You would have to do the correct wrapper for it to make the changes, but that would be completely possible. You would basically take the output and you'd have to put it into like a commit script format. So it would be a little bit different than what we've demonstrated to here today, but it is something that's possible. If you want to hit me up via Twitter, we can chat offline about it later in the week, or do some emails back and forth, please do, and then we can do that. Or if you have a question, you can hit me up at robc juniper.net if you're not in the Twitter greater perspective here. So in our short period of time that we had here today, I hope that we took a look at what's some of the basics that are possible with scripting, how it is to get started, and then just kind of reaching out there to see if people would be interested in a tool that would take the scripting out of scripting and make it a little bit simpler to do some of these basic configuration scripts. So just go ahead and provide that feedback to us, and we'd be very interested in that. We have another question here. And the plan a presentation to convert ScreenOS to Junos configs. I have not, but if Norman, if that's something that's of interest to you and many other folks, that's something that we could definitely look at talking, maybe between now and the end of the year, depending on the webinar scheduling. So just please provide us that feedback if more people would like to hear that, and we could definitely talk about an effort about converting ScreenOS configs to Junos by hand or using the S2J tool. I'm actually part of the committee that's working on the next generation S2J tool, and next generation, don't think it's spaceships and magic. It's just something that, as we're continuing to evolve the program, and so I'm consulting on how we're doing that and expanding the S2J tool. Norman says yes, so I will work with the Juniper folks here to perhaps have another webinar between now and the end of the year to discuss, you have ScreenOS, you need to go to Junos, what do we do, best practices, and I'd be happy to do that. Awesome. So as we kind of wrap up here, if there's no other questions, I just want to say I appreciate everybody joining here today and learning a little about Junos scripting. I feel that while you can't take a Junos script and make it to parse, IPv6 in real time with IPS signatures, I mean, again, you can't do deep data plane stuff. A lot of your challenges through Junos or simplifying tasks can be solved through the scripting pieces. So I think it's something that it definitely gives you an edge in the Junos community to be able to do this. And if you're a consultant or VAR, you can take very, very complex things, make them into a script. Like I said, I built some scripting that you can see on that website, the task agent action agent, that is used for many very large customers for doing some advanced HA features that we still do not have built into the SRX. An example of that is we have what's called follow the leader, where in HA today we have the control plane and data plane on different devices. So like you could have active control plane on device A, but active data plane on device B. And for administrators, this may be confusing, as we've seen in the past. So the script actually calls and does follow the leader, and it makes the control plane follow the data plane wherever it goes. And it's just something that, from a feature perspective, it's interesting, but not the necessary way we want to do it default in HA, and just a script that we use in many, many, many customers today. So an example of some of the advanced things you can do with scripting features. So I hope this got you started with scripting and found interest. Please, take a look at that day one book. It goes over this a lot more simply and focuses on Slacks, which I definitely think is a lot easier to use. And I appreciate everybody joining here. And again, if you have questions, feel free to hit me up. I appreciate the time, and I'll look at trying to schedule a best practices migrating ScreenOS from Junos config with the webinar team. So thanks, everybody, and enjoy your day.